Okay. Well, we will continue with what we were doing in terms of the modeling. And today, as we have said in the last lecture, we would like to get the transfer function, okay, for the DC motor. Well, remember we said the DC motor, it has two windings, one in the stator, okay, and one in the rotor. This is the rotor. Okay, by supplying a current to the stator winding, we are going to get a field, and in if we also supply a current to the rotor, we are going to get another field. Those two fields will interact and they develop certain torque, which will ultimately give us the motion. We said, okay, we can model in terms of the circuits, we can model the field by a voltage source, okay, since we have, coils, so a resistance and inductance. We'll put resistor and inductor, okay, and this is the field. The armature will be the same. The only thing in here, in the armature, since again, I'm rotating a coils in a magnetic field, then what I'm going to get certain back EMF. And this is the voltage. And the voltage usually, it's opposing the armature voltage. And I will collect the motion through a shaft in which I can connect this shaft to a load where I would like to use this motion or the position. What we want to do now, okay, what we want to do in this lecture, we would like to find the transfer function between theta is our output over VF of S, keeping, in this case, keeping IA constant. Or I would find theta M of S over VA of S, keeping IF constant. So by the end of this lecture, we should be finding theta M to VF or theta M to VA. If we keep the armature current is constant, we call this device field controlled DC motor, because I'm controlling the DC motor from the field side. While if I keep IF constant, okay, I will be controlling the system from the armature, and I will call it armature controlled DC motor. In here, we don't vary both of them. We don't vary VF or IA and IF simultaneously. If we do that, we could get a model. We could get theta in terms of both of them. However, the model is going to be nonlinear, and we cannot find a transfer function. So at a time. Any question?
Yes, Doctor. Is IA the current induced only by VA or the total by VF and VA?
كيف؟
يعني هذا مو يعتبر زي ترانسفورمر انه VF will create a current that will go through the loop of VA?
No, it is not. No, not transformer. Not at all.
No. It's not like a transformer?
No. Look, IF will produce certain field. You are passing a current in here through coils. What will happen? You induce voltage. sorry, you produce magnetic field. And
Yeah.
in the other circuit, in the other winding, also you are, you are injecting certain current that will give you another field. Those two fields will interact with each other. So it's not transformer, no.
No, but I mean, wouldn't that vary IA as well? This induced current?
We vary. Okay, we are varying. As I said, we in this case we are varying one at a time. We can vary both. Okay, and you will get a relationship between them, but the relationship between theta and VF and VA is going to be nonlinear relationship.
Okay.
Okay. Now, last time I think one of you asked me. Okay, I think Abdurrahman asked. I don't know, Abdurrahman, do you ask about what's the difference between the two and where is the application for the two?
No, someone different.
Okay.
Yes,
Why I need field control or armature control? What's the difference between the two in the application? We are going to see that the armature control DC motor it has a feedback loop in it. It's built-in feedback loop. While the field control DC motor, it is an open loop system. So definitely the built-in feedback system will be better. Okay, if I need a variable speed, usually we will use the armature control DC motor. But the field control DC motor, it has an advantage. It is cheaper, and also the losses will be less. It is more efficient. So it depends on the application. As I said, we could use, each one depending on what exactly we want. If we want variable speed, usually they will go to the armature control DC motor. So now, as I said, what we want to do, we would like to develop the relationship between theta M and VF, theta M and VA. But before that, let's talk about some basic. Okay, I am passing a current through coils. What do I get? What do I get?
Magnetic field.
Magnetic field, isn't it? Which is, you measure it in terms of the flux. And the flux proportional to, okay, IF. Okay. There is flux. The flux is proportional to IF, provided that I am, working in, okay, provided that I'm working in the linear region before the system is saturated. Because if you have coils and you keep passing current, what will happen? What will happen?
Magnetic field will.
Yes, but do you increase the indefinitely? Do you increase the?
No, it will saturate.
Of course.
It will saturate. So what we are saying, we are talking about this relation as we are, making the motor working in the linear range before this. Okay. Now, there is another relationship. I'm passing a current through this one, I'm producing magnetic field, and I'm passing a current through the coil, through the rotor, sorry. Okay, so you will have two fields. They will interact. What do they produce? What do they produce? Two magnetic field.
Force.
What?
Force. They will use force.
Torque, yes. They induce torque. So I will have a torque, okay, call it Tm. This is proportional to Ia, If. So the torque, okay, the torque is proportional to the field current and the armature current. And this is where the nonlinear relationship, as I mentioned here. So when we want to solve the system, when we want to find the transfer function, we would like to keep one of those variables constant. If this is constant, if IA is constant, we call it field controlled DC motor. If IF is constant, we call it armature controlled DC motor. Okay, we need one.
دكتور
Yes.
if IA constant, it means also that VA is constant, right? Or
If IF constant, it means that the field is constant. Yes, phi is constant.
okay.
Okay. So we have one more quantity. Again, one of you asked me in the exams, do we have to remember all? Those are basics. Okay. Those are basic. I don't know. I mean, it's by common sense. One more thing. Back again to in here. You are rotating coil in a magnetic field. What does that will produce?
Angular velocity.
Yes, no, no. Coil, okay, look, there are two things. Once we are saying I'm passing a field, this is a field, and this produce another field, they will interact, they start rotating. Now, when this coil start rotating in a magnetic field, what does it produce?
Mechanical energy.
Electrical, okay.
Yeah, of course.
Use
Electrical
voltage.
energies. With
It
the
will produce
brush.
voltage.
Yes.
Okay. We call it the back EMF voltage. Okay. So the back EMF voltage is proportional to the speed of rotation and the field. If I keep the field constant, then VB, the back EMF, proportional to the speed of rotation. I need, to develop my transfer function, I need those three quantities. Okay. Any question here?
The last point, you need what for what?
I need all of those quantities in developing the transfer function. Remember, we would like to obtain theta M to VA or theta M to VF. In the process, I need those quantities.
Okay.
Okay. Now, a DC motor with a fixed armature current may be controlled by the field current and is known as field-controlled DC motor. Okay? A DC motor with a fixed field current may be controlled by an armature current and is known as armature-controlled DC motor. We will see the transfer function for this one is going to be a little bit different from this one. This is an open loop system. This is closed loop.
Doctor,
Yes.
I have a question. Closed loop, it means it's more linear or not?
No, closed loop, no. Closed loop, no, it's linear. It doesn't matter. Basically, what we are saying, remember what's an open loop? You have suppose I have a system, this is G transfer function. This is, let's say, Y, and this is R. Okay. The output is not being affected, the input is not being affected by the output. I call it open loop. The closed loop, I'll take the output and compare it. Let's say I have another transfer function here, H, call it H. This is R. Now I'm taking the output, this is usually minus. I'm comparing it to the desired, we call the output. So the system is still linear. No, it is linear. You could have, I mean, you could have nonlinear feedback system, yes. But what we are going to talk about in here, no, it's linear system.
Okay.
Okay. So we, as I said, we will be deriving the transfer function for both types, one at a time. So let's start by assuming IA is constant. The current in here is constant. Find theta m over, okay, over VF.
دكتور الاندكتور will be short circuit ولا كيف؟
كيف؟
الاندكتور will be short circuit.
No, not short circuit. No, you are keeping it constant. No, if you, what do you mean short circuit? What?
DC current.
No, just constant.
No, the idea in the inductor, if it's a constant current, so the LDI by dt will be 0, right?
Yes, but don't forget, you have rotation also. So VB, you are producing the certain VB, which will, you know, there will be certain, you know, I mean, the system will work because there is certain rotation as well.
I see.
Okay, but it is no, it is not 0. It's constant.
Doctor,
Yes.
are we interested to find the transient response? Or only the state?
Are we going to do the transient response?
Yes.
Yes, we are. Yes, we are. In the transfer, if you have a transfer function and you give me the input, I can get to the output. So the, okay, it will be having both transient and steady state as well.
Oh, okay.
When we go to frequency domain, frequency response, okay, we will be having only the, you know, steady state, not the transient. But in here, no, definitely we will have the transient response. Okay, now let me establish the relationship between VF and IF. What is IF of S equal in terms of VF of S, of course. What is it equal to? What is IF equal to in terms of VF? Let's assume that we are, you know, working in the, we will be having the, we are working in the impedance. So what's IF equal to?
1 over RF LFS.
Exactly. RF plus SLF. So let me put them in a block diagram representation. My input is VF. 1 over RF plus SLF. And this will be IF. Do you agree?
Yes.
Now.
Yes, doctor.
Okay. Now, let me come. Okay, the torque, the developed torque, Tm. What does the developed torque proportional to? Remember,
proportional to the two fields.
This is the Tm equal
two currents.
Kf, If, Ia. Ia is constant, so
with the K.
It will be Km, let me call it another constant, If.
So it's just a gain.
It is just pure gain, exactly. And usually it's given in any problem, in any, with the specification of the system, you will be given that this is the value of Km. So, Km, and this is Tm. Now, in the load side, what is the relationship between, okay, so this Tm is the developed torque, okay? The developed torque, okay, it will be transmitted to the load. However, if we have, suppose I have a disturbance in the system. If I have a disturbance in the system, what is TL will be equal to? What do you think?
The current induced by the other board. So
It's going to be Tm, the developed torque in the motor, minus the disturbance. The disturbance, something is unwanted. Usually it is 0. But
So this is the torque in the load,
what?
the torque developed in the load, or no? TL.
The developed torque in the motor, and the motor will be connected through the shaft to the load.
Right.
Okay, so the TL, what is going to the load, equal the developed torque of the motor minus some disturbance. If the disturbance equal to 0, then this will go. So TL equal to Tm. If not, you can model it in this way.
Victor, the disturbance here mean the friction.
No. This, okay, if you remember we said, suppose this is a motor, is holding your antenna in the roof. The disturbance could be a wind. So it's not the friction. The friction come here. The constant for friction is B. And this is TL.
So it's outside the system, TD.
What?
TD is caused by something which is outside of the system.
Exactly. Okay. Most of the time we consider it to be 0. But if it's not 0, just model it.
Just add it, yeah.
Just add it, subtract
Minus.
it. Okay, now let's work on the TL in terms of theta. What's the relation between theta and TL?
We know that TL, is connected to the angular acceleration, which is this second derivative.
Apply Newton's law in here.
Right.
So Newton's law, since this is rotational motion, what did we say?
Moment of inertia multiplied by the angular acceleration.
Summation of torques must be equal to J times alpha.
Right.
What are the torque which we have?
TL.
TL.
Also, we have the
Minus what?
Minus TD.
The friction.
The friction, right.
So the friction will be, the friction proportional to what? Shabab, the friction proportional to what?
to the speed.
Speed. And the speed in terms of theta equal to what?
D theta by dt.
The speed is omega.
D theta by dt.
Theta dot. So if we are
Theta
talking
dot.
about transform domain, this is going to be S theta.
Right.
This must be equal to the moment of inertia, which is given.
B, doctor, is just a damping factor, right?
KF?
B is the damping factor.
Yeah, a damping factor, yes. Or
Yes.
friction.
Or the friction. Yes.
Okay. Times alpha. What's alpha equal to in terms of theta?
Theta S square.
Theta of S.
Without the initial condition.
No initial condition. This transfer function.
تمام.
Zero initial condition. So, in terms of TL, theta of S equal to, solve for it, take this one to the other side and factor the S out. So S times JS plus B. Okay, 1 TL. Any question here?
We can find the
So now,
response.
let me connect here. 1 over JS plus B, 1 over S theta.
Why, doctor, you separate the two? 1 over S and 1 over J.
Why did I separate the two?
Yes.
Okay. Any volunteer, Shabab? Any?
Because one of this is an integrator. We know it.
Which is exactly what?
J of T.
Which is, remember,
You.
omega. If I need my output to be omega, not theta, I can get it directly. Can I? You tap in this point. Look, this omega equal to, we said, what did we say? Omega dot equal to theta, isn't it? So,
the vice versa, wasn't it? Omega is equal theta dot.
no, omega, omega equal theta dot.
Yes.
Or theta equal to integral of omega.
Right.
Over S is integrator, isn't it?
Yeah, because it's the
Okay.
step response.
So that's why, you know, sometimes we separate them. You don't have to separate them, but we usually separate them in case you need omega. Now tell me, if I need theta m over VF,
we just multiply multiply Km, of course, by 1 over Rf plus SLF.
so basically you multiply the gain of all the boxes.
Right.
Assume that
So
T
you are
equals to 0. I need the transfer function between theta m and VF. So in that case, you assume TD to be equal to 0. And then if this is the case, then my transfer function is going to be Km over S JS plus B times RF plus SLF. And this is the transfer function.
If we have
Doctor,
the disturbance.
If you have what?
The disturbance.
The disturbance you can also find.
We have to add it at the after we multiply the two.
No, wait. Theta m to TED. And you assume VA equal to 0. This is the way. Because TD can be considered as another input because it's constant. I mean, it's external, not necessarily constant, but it's external. So TD, if I want this one's going to be what? 1 over S times JS plus B.
But this should be Dr. TL, not TD, right?
Which one?
Multiplying 1 over S multiplied by 1 over JS plus B should give me
if you want, okay,
theta M over TL.
No, look. If you want the transfer function, you will use superposition. Okay?
I see.
Superposition, I have to input. Let me first, I assume TD equal to 0. Do you have any problem?
No.
Okay, so theta m will be 1 over S times this one, times this one, times this one. That will give me this transfer function. Now,
Right.
assume VF equal to 0. What do you get? You will get minus 1 over S JS plus B.
You assumed what, Dr. Manish?
You assume VF equal to 0.
VF.
Okay. If you want the transfer function, this is the way, this is the way you find transfer functions. But anyway, our focus in this transfer function. Any problem here? Any question here?
Doctor,
Yes.
can you please repeat how did we get theta s?
Okay. Theta s from here, this equation.
Yes.
Okay. What we said, I will apply in Newton's law to the rotational part. Let me clear this one maybe. What I'm saying, suppose I have, this is the load, or this is the motor. This is my motor, okay? It has the moment of inertia, it's J. What are the torque for this load? What are the torque we have? What are the torque, operating on the load? The developed torque, which is Tm or TL, let's say, after, assume TD, assume TD equal to 0. So Tm and TL, they are the same. Okay, so this is Tm, let's say, or TL, okay? So it will move it in one direction. What are the other torque in here? Which torque will be?
The friction.
The friction. And what is the direction of the friction will be?
Opposite.
Opposite, which is basically B, okay, omega. So if you apply Newton's law in here, I have Tm or TL minus, okay, minus, let me call it TL to be in the safe side, minus, okay, B omega. But what's omega in terms of theta? Omega equal S theta, the derivative of theta.
So it will be S.
So it's going to be S theta. This must be equal to the moment of inertia times the angular acceleration. What is the angular acceleration in terms of theta?
S square.
S square theta. So now I will have J S square plus BS theta, sorry, BS, I factor the theta out. This is equal to TL. So theta equal to 1, here TL, and let me take the S out. Okay, and this is basically what we have said.
Yeah, it's clear, Doctor.
Okay. Any other question? So this is basically, more talk of the same thing. This is the transfer function. And this is basically what I have said, the block diagram. Any question?
Just, Doctor, to confirm what you have said, when we want to find the transfer function for another input, if we have multi-input,
Yes.
right? So we
Yes.
set all other inputs 0, like superposition.
Exactly.
Right?
Exactly.
Then we
Exactly.
find the transfer function associated with that input.
Exactly.
Because when we set if 0, so the Tm will be 0. So the only input we will have is the TD minus TD, in fact.
Exactly.
So
exactly.
we'll have only the two other boxes in the,
That's
at
correct.
the end of the, yeah.
That's correct. That's absolutely correct. Okay.
Tamam.
Now, let's go to the other one. Let me fix IF now. And now the objective, find theta M over VA of S. This is now the objective.
Similarly, we'll do VA is equal to.
Okay. So, no, let's take IA.
Yeah, we can take IA.
Okay. IA equal to, what's equal to?
RA 1 over.
Okay. RA plus
SLA.
SLA times what?
times VA minus VB, right?
Exactly. Look, just apply KVL here.
Exactly, yeah. Mesh.
IA plus SLA IA plus VB equal to VA. Okay.
No mesh analysis.
Doctor,
Yes.
are we assuming that the motor has no resistance, or
The motor has what?
are we assuming that the motor has no resistance?
The RA, what's RA?
Or no, I mean in this question, are we assuming that the motor has no resistance, or
What do you mean no resistance? How? No, what we are assuming in this case, the field current in here is constant. The resistance in the, okay, in the armature, RA, in the field, RF. So we are not assuming they are zero. Why do you assume they are zero? This is RA.
yeah, right, yeah. Thank you.
Okay. So RA plus SLA times VA minus VB.
Doctor,
Yes.
don't we have a mutual inductance between LA and RF?
No, this is not transformer. What you are saying, okay, even if you have, assume it is extremely negligible. You don't model it in that, no, you don't consider it.
Okay.
Okay, so now.
By the way, Doctor,
Yes.
is it VA minus VB or VB minus VA?
Yeah, Abdurrahman, this is KVL.
Yeah.
Okay.
المفترض
RA,
by convention.
IA, look, wait. RAIA plus SLA IA plus VB.
VA.
Okay, so.
Yeah.
Okay.
Yeah, right.
Because look, the back EMF, it must be opposing VA.
Yeah, of course.
Okay.
Otherwise, we will not have a rotation.
Exactly.
تمام.
Okay. Now, let me put the block diagram. Suppose I have, this is VA. In here, I have a summing point minus VB. This is minus sign and VB in here. What is VB? We'll come to it. And in here, I will have 1 over RA plus SLA. Okay. So this is IA. Any problem here? Okay. What else we have? We have the, okay.
Torque.
The torque. Well, before the torque, what is VB equal to? VB equal to what?
Again with the free gain of just a pure gain with the IA.
And what? And proportional to what?
To magnetic field.
We said no, yeah, but the field is constant. If you remember this relation. VB proportional to the field, yes, and omega, but the field is constant because we are assuming field control, the arbitrary control DC motor in which the field will be constant. So
Understood.
V times omega.
Right. So the flux and the K will be just constant.
Abdurrahman, there is an ecosystem in. You have an ecosystem. Okay. So this is going to be. Okay. KB, let me call it constant, times omega, which is equal to KB. Let me put it in terms of theta. So if I want to put it in terms of theta, what do I use?
S theta.
Theta. Okay. So, okay. I will come to it later. I'll connect it later. Now, the developed torque, TM, What's Tm equal to?
Is K multiplied by the two currents.
Km by Ia. Remember,
Right.
Tm proportional to K, Ia, If. If is constant now. So I included in the Km. The constant.
Yeah, this is the Y aslan. We put one of them as constant, so to avoid the multiplication of the two.
Exactly. So this is Km. Now, again, assume I have the T load. The T load will be what?
Tm minus Tb.
Minus if there will be a disturbance. So let me model it in this way. This is my minus, this is disturbance, another input. And in here I will have, this is my TL. Okay, TL, let's apply it to the mechanical, Newton's law.
Right. The moment of inertia and the
Exactly. So TL, okay, TL minus.
So it would be the same as before, right?
Exactly. B S theta equal to J S square theta. Okay.
Okay.
Okay. Now let me solve for theta in here. I will have, okay, S JS plus to the other side, BS, B, okay, theta equal to T, let me call TL, sorry, TL, or theta equal to 1 over S JS plus B, okay, TL. Let me put it in here in terms of block diagram. So I will have 1 over JS plus B (1 over S). This is theta. Now, let me feedback VB from where I do my feedback.
down here in the box that you have looked.
And this is my block diagram.
Doctor, why is the feedback from there?
Because look, look, in the transfer function, you should keep theta and VA and eliminate anything in between. Okay? You eliminate anything in between. So now we said VB equal to KB omega. If this is theta, where's omega?
Omega before.
Before the integrator. So this is omega. I'm feeding omega. Multiplied by KB, I'm getting VB. Okay, subtracted from VA, and we'll get. Okay. Later on, we will be, there is a feedback. Look, in here, there is a built-in feedback system. There is a built-in feedback system. Later on, maybe within 2 lectures, we will be reducing the feedback into 1 block. Now,
Is it 1 block, Doctor?
I need theta to VA. As I said, if I know in the feedback system, I can reduce the entire thing into 1 block and then multiply. But look, suppose we don't know the feedback system now. From here, what do we have? look, take TL in term of, or theta in term of TL in this equation. Okay? But TL equal to what? TL equal Tm minus Td. You substitute in here. But Tm equal Km, okay, times Ia. This equation substituted here. And for VB, substitute KB as theta. So what I'm trying to say, it is a process of elimination. Let me show you exactly what I mean in here. This is VA. Do you agree with me? Okay. This is KVL. Okay. Or IA, as we have said. This is TL. Now, if we equate, assume now, let's assume for a moment, okay, there is no disturbance. There is no disturbance, that Tm equal to TL. Okay? If there is no disturbance, assume the disturbance equal to 0. So what do I have? We said theta. So this equation, I will have Km, okay, VA minus KB S theta over RA plus SLA. This is equal to, okay, S JS plus B theta. Can we solve for, now there is a relation only between theta and VA. Do you agree? Only
Yes.
theta and VA. Solve for theta in terms of VA. If you solve, this is basically what you'll get. This is what you'll get. Okay? Sometimes we neglect the effect of LA. If this is very small, then you can reduce, rather than working third order system, you will be working with a second order system. Again, this is basically what I have derived before. Okay. Later on, what we can do, we can reduce. Let's assume, let me combine this one, call it G1. Okay, this is TD. This is another, okay, this is, wait, sorry, G2, where G2 is equal to this quantity.
So why do you use G letter?
I just combine rather than, because it will be complicated for me. G equal to multiplication of those two. We can multiply.
Yeah, I know, but why exactly G letter? Because I noticed in the textbook they use G letter. Is it because something, the G?
No.
Just arbitrary.
If you don't like it, call it A, Abdurrahman, A of S.
But sometimes
whatever. No, it is just matter of symbols. No. It has no meaning. Sometimes they use H, they use T. The overall system, they use T also. So it's no, it has a, there is no, yeah, I mean, there's nothing there. This is KB. And this is 1 over S, theta S. Okay? If, assume TD equal to 0, okay, let me take the relation, let me call this is, this is omega, isn't it? Okay.
Yes.
This is VA. And let me call this one E, error. Okay? So, what is the error equal to? Error equal to what? V
VA minus VB.
minus KB omega, which is S theta. Do you agree?
What?
Now, what's omega equal to? Omega equal in terms of VA. Omega equal also G1, G2 times E.
Right.
So this is equal to, then basically I will have omega equal to G1, G2, VA minus K, B, S, theta.
Yes. And omega is S theta.
And omega also is S theta. Okay. So basically I can solve for, okay, I can solve, okay, let me for the time being, in order, this is, okay, call this is omega also.
From that, we can find the transfer
Okay.
function.
Exactly. So basically solve for omega in terms of VA. So omega 1 plus KB, okay, equal to G1, G2, or times VA.
لحظة دكتور كي بي مفترض
Equal
multiplied by G1 G2 right؟
What?
الكي بي هنا في ال 1 plus
Yes,
كي
yes,
بي.
yes, yes.
Yes, it's correct. Yes, yes.
Yes, you are right. Thank you. So it's going to be 1 KB G1 G2, or omega equal to G1 G2 over 1 plus KB G1 G2. Okay, VA. Okay, if you want theta, multiply by S, everything multiply by S, and you will get it. So basically, we are going to come later on, and we talk about, you know, if we have a feedback system, we can reduce it. But this is basically the derivation. So the difference between the two model, sorry, I'm going over time. The armature control DC motor, it has a built-in transfer function. Built-in, sorry.
يعني دكتور next steps يعني what you are doing here E equal to omega مش عارف ايش after we يعني derived the whole system you are trying to simplify the system.
I'm trying to show you this can be, you know, done either you go direct substitution, or later on when we talk about what we call a feedback loop, we reduce this feedback loop into one block. This is what I want.
I see now. يعني reduce this to one block.
Yes, and multiplied by the other.
I see.
Similar. Oh, look, in the open loop system, in here, the transfer function will be the multiplication of all the blocks. If you have feedback system, we reduce the feedback system into one block and then do the same. But anyway, you don't have to know the feedback. We will come to the feedback system, inshallah, in the not next lecture, lecture before, after maybe. Any question before we stop? Any question?
Doctor,
Yes.
will we be given like different systems and we gonna derive the transfer function of it, or is it just the DC motor for now?
I didn't get. Say that again, please.
Like in an exam, will you give us a different configuration for the
Yes,
DC motor?
yes, we could. There is a possibility. No, wait for next lecture. There will be the, you know, the gears, when you have the gears. So yeah, yes, you could have a question like this. But look, you are going to have in the lab, you are going to study this one in more detail also.
But what I can see, Doctor, from here, that all what we have is just simple KVL, simple KCL, and simple Laplace transform, and that's
exactly,
it.
Exactly. Believe me, the problem is we always think things are very complicated. But if you simplify it, look, what we have done, yes, you are absolutely right. What did we do? KVL, KCL, and Newton's law. That's all. Combine them, put them together. بس هو احنا الامبريشن oh, this is very hard. No, you know, you have seen it. It's extremely simple.
Yes.
But
Thank you.
as I said, it is perception.
Right.
Okay.
يلا يعطيك العافية.
Oh, sorry to keep you over time.
The time goes very fast with the class.
حياكم الله يا شباب.